Yeah. All right. So, because I spend all this time giving away books, you can imagine we are behind time, and I'm just going to kick it over to you. Go ahead, and I'll talk to you in 25 minutes.
Sounds good. Okay. Uh, Hi, folks. So my name is Ellora Praharaj. I am the Director of Reliability Engineering at Stack Overflow. My teams are responsible for maintaining all of the infrastructure across the entire company. We build the common platforms and maintain the tooling, which other engineering teams build on. And we're also responsible for making sure the public sites, Stack Overflow and the SE network of sites, stay up. As you can imagine, anytime they go down, we get a lot of people yelling at us on Twitter and other social media sites. Next slide, please. Okay, so I am going to chat about what do gas stations and DRE have in common. Next slide. So this is a picture that I actually found on one of our network sites, about 100 plus years old. This is what gas stations used to look like. Next slide, please. This is what they look like now. If we can move on. Okay, so when I say self-service, what does self-service mean at a gas station? Next point. So you pay at the pump. Next. No need for cash. You can pay with a card. Next slide. Next point. There's no need to go inside and talk to a cashier. You don't really need to go physically inside a store. Next point. You get to pick your fuel grade. Next point. So you have control over what you're filling into your vehicle. Next point. You're going to lift the nozzle and pump. Next point. And there's no waiting for someone to come around and pump it for you. Next point. And you end up controlling the amount that you fill. So as a user, as the owner of the automobile that I've driven up to this gas station, I am able to self-service my gas needs. Next slide, please. Okay, so there are a few things that we do need to consider when we're talking about self-service at a gas station. Next point. So next point. What type of gas should I be choosing? There's diesel versus petrol, and there's different grades. Next point. How much gas do I need to fill into my vehicle? Next point. Very important. How do I not light myself on fire? Next point. What if the pump runs out of gas? So these are certain questions that we have to be willing to answer, and we have to know before we can go ahead and fill up gas. Next slide, please. Yes, I know we're a DRE Con, so I will pivot. Next point. So what we're going to talk about today is, next point, self-service with respect to databases and what that means. Next point. What is a journey of a DBA to what we consider now a DBRE? Next point. I'm going to touch on automation, and what I'm going to dive into a little bit is automating stuff, but what exactly that stuff means. What is my perspective? Because it can mean different things to different people. Next point. And then finally, embrace failure. This is kind of related to what Joe talked about earlier in terms of failure, but I'll talk about it from a slightly different angle. Next slide, please. Okay, I know I said I would shut up about gas stations, but remember that mapping exercise? So what we're going to do is go through each of these in point and dive a little more into them. Next slide, please. So first up, what type of gas should I choose? Next point. It is analogous to picking the right database solution. The things to consider when picking the right solution are, well, what are the application needs? What is the organizational support for it? Does my organization even support like XY or whatever my favorite database is? What are the cost constraints? Next slide. Next point, please. So how much gas do I need? That essentially translates into the amount of compute units that I would need for my database. How much memory should I expect? How much bandwidth would I need? What kind of CPU am I looking at? And that's computed really based on the expected load. Are we talking about megabytes of data, or are we talking about multiple terabytes of data? It depends on the performance needs because, well, do we want the performance to be the order of milliseconds? Or is it going to be something on the order of minutes, which might be a batch job that just runs quarterly that people look at it very rarely? And then finally, we want to make sure that we have the right observability in place so that we can tune these needs as we go along. Next point. Next point, please. Okay, how do I not light myself on fire? Very important. How do we make sure that we're preventing, and as Smoking the Bear says, right, only you can prevent forest fires. So we can prevent getting ourselves into trouble by following good software engineering practices. There's going to be a heavy focus on automation, and I'll get into that a little bit later. Leveraging CI/CD pipelines, and then definitely making sure to keep security and privacy considerations in mind, because as with data, there can be often times that we would end up storing sensitive data. By following good principles there, we would be able to avoid most issues. Next slide. Now, if the pump runs out of gas, well, issues will happen. Even if we've managed to not light ourselves on fire, there might be things that are external to our control. And in that case, we want to make sure that we have proper incident remediation processes in place, which talks about SLOs and SLIs. And we'll delve into that a little bit later as well. Next slide, please. So traditionally, a DBA has been responsible for designing, implementing, and managing databases, emphasis on the responsible. They're the subject matter experts in database systems and technologies. Unfairly, well, sometimes fairly in my experience, they can get labeled as grumpy gatekeepers. We've traditionally been in the business of treating our data stores as pets, not cattle. And when you need to manage databases hands-on, the amount of toil really starts adding up. One way to manage that is by increasing the number of people supporting it, or we can look to DRE principles to enable scaling up. Next slide. So yeah, when we're talking about the next step in evolution of DRE, the database reliability engineer comes in. Here, emphasis on facilitates. A DBRE facilitates the delivery of reliable database platforms. They are someone who work in collaboration with multiple stakeholders, not just the engineering teams, but all the way from business and product. And they essentially focus on common repeatable tools and processes. The idea is here really facilitating that self-service by helping teams address the data needs themselves. There is no throwing stuff across a wall. As Joe mentioned, if you want to fail, make sure you build silos. We don't want to fail, we want to succeed. So we're focusing on not making silos so that we can have more cross collaboration. It's not just going to be the case that one team says, yep, this is what I've written in my code and this is the stuff I've done with data. Now it's on the DDRE or the SRE to go ahead and deploy into production. We don't want to do that. We want to enable those teams to be able to do their entire pipeline end to end themselves. That's where automation comes in. And like I've been saying for a couple of slides, we will jump into that a little after this. There is an initial learning curve, but the beauty of this is once you do it, you don't have to do it again. So if you remember the mapping exercise where we talked about what type of gas do I need, how much gas do I need, how do I not light myself on fire, those are the things that enable self-service for different teams. And a DBRE is the person that can really help facilitate that change. It's a mindset change. It's not just a technical change. It's also a cultural change. And I really view SREs and DBREs as the folks who are leveraging that. The difference here between a DBA and DBRE, as I've highlighted in the slides as well, is that a DBA is responsible for certain things and a DBRE facilitates certain things. Next slide. Okay, so I've been talking about automation. Next point. What do we mean when I say automation? Because it can mean different things to different people. So some of the things that I've focused on through my career and what we're doing, some of these things that we're doing at Stack Overflow. Next point, please. Is leveraging infrastructure as code heavily to do provisioning. Next couple of points. So what this means is you want to be able to set up and configure your database server via code, not just having to log into a machine and do it manually by clicking around or running certain commands, but really codifying that. The advantages of setting up that setup and configuration infrastructure as code means we can test it, we can have it run through pipelines, and we can essentially have it run as part of a compute setup. For example, if let's say one of my SRE teams was able to set up a VM and now we needed to install some kind of database server on it, we wouldn't need to have this handoff process. It could just run as a post-install hook. And then, hey, magically, you just get, if you label that, you say, well, I want this VM to be of type database, you would just get the VM of type database that you wanted. I put in no touchy prod here. It's very, very important that you try and stay away from SSHing or RDPing into your production machines. preferably all of your pre-prod machines as well, but definitely for the production machines. We want to make sure that there's enough observability, there's enough metrics and logs and health checks that allow you to observe what's going on in your systems. In terms of patching and upgrades, because we will have to deal with that. Again, that's not something that we want to do manually by SSHing or RDPing into machines. We want to codify that with infrastructure as code, so we are able to handle those in an automated fashion. Next point. Bonus points for disaster recovery and failover tests. We want to make sure that our systems are resilient. And if one side, let's say one site goes down or a zone goes down, we should be able to fail over gracefully. Having a disaster recovery plan and doing regular failover tests definitely helps in that. And we want to automate as much of that as possible. Next point. This is the one exception, I would say, to no touchy prod, is where there's a break glass scenario. Essentially, you want to have a backdoor if there's something that blows up, an incident is occurred, and we'll talk a little bit about incident remediation as well. But you want to be able to bypass the checks and controls to be able to fix the outage right away. Again, that should just be like a last resort. It shouldn't really be something that you rely on regularly. If you find yourself in the pattern of relying on break glass scenario regularly, it sounds like it is ripe for automating. Next slide. Okay, another great example that I've come across in my career is, next point. Hey, can you run this query for me? So a lot of times application teams will come in, they have all the context, none of the access. Next point. DBAs have all of the access and some of the context. So what's the solution here? Well, we could talk about building out self-serve query runners in which the DBREs enable the application teams to be able to self-service and run the queries themselves, the types of queries that they want to run. What are some of the things that we would have to keep into consideration? Next point. We want to make sure that there's an approval process in place. Similar to like how we have PRs in GitHub, you want to make sure someone else is signing off. So, two pairs of eyes is better than one. We want to make sure that the person who's running those queries has the appropriate permissions. So robust RBAC systems would really help here. A lot of times data can be restricted. So you want to make sure that the person running that query actually has the access to be able to access that kind of data. And then finally, audit everything. Your InfoSec folks are going to love you. This is really, a lot of companies need to do this for compliance purposes. Again, with PII, and not even just PII, just in general, being able to walk back and see how the system has changed, especially if it was, especially if it was right type of operations that were being run. Like if someone was trying to update something in the data, you want to be able to see what changed, and if needed, roll it back. Next slide. Okay, next point. So again, talking about more automation, in terms of DDL changes, what I prefer my teams to do is to leverage a CI/CD pipeline. You want to make sure that you're running the schema changes in a lower environment, testing it out before promoting it into the next environment. Next point. And that's where automated testing comes in. Sometimes you can't get away with fully automating stuff. You might need to have like some kind of a user-focused test, but the preference is always to do as much automation as possible. In terms of DML changes, it might not always be feasible. Next couple of points. It's not always possible to be able to completely mirror a production database. Now, from an application perspective, we absolutely should not be testing on production. We should be able to do all of the tests in a pre-production world. In the database world, if we had a true representation of prod and we were confident that running tests there were able to give us what we needed, then that's great. But in a lot of cases, due to cost constraints or complexity constraints, we can't. So the ideal is to have some representation of production that you can run the changes in, validate that the data changes don't break, and then be able to run those out. Talking about CI/CD here. So next couple points. We want to make sure that we have really small chain sets that are flowing through the system. And whenever possible, we want to be able to test database and application changes independently. Following these principles really helps in an automation journey and adds in extra guardrails, which enables self-service for other engineering teams. This is what I view the DBREs and coming in and facilitating. Moving on. So yeah, like Joe said, similar. Embrace failure. Next slide. Next point. Stuff is just going to break. That's just a way of life. And we just have to figure out how to plan for it. The biggest thing is, well, when something does break, make sure that the focus is immediately on restoring service. You don't want to leave your users or your customers hanging. Next slide. Next point. That means we have to have a planned ahead, robust incident management process in place. Next point. Have a rollback strategy, especially if there are some big changes going out. Make sure you have a backup plan. What should I do in case this goes boom? If a rollback strategy is not always possible, again, due to complexity and cost, make sure that you're designing for easy fix forwards so you can quickly put in fixes to restore service. Next point. And then make sure that your change sets are small. This is where the CI/CD pipeline really comes in beneficial because you're not having to run those things manually. You can have essentially an automated pipeline run through the entire changes for you, and it allows you to keep your change sets really, really small. That minimizes the blast radius as well. One other thing I want to point out in terms of restoring service quickly, in my experience again, and this still happens, a lot of times I've seen people really want to jump in and start like investigating the root cause as to why something broke. Resist that urge. You want to make sure that you're, again, solving the immediate problem by either doing a rollback or a roll forward and restoring service. The retros can come later. You can have a postmortem later where you have all the time to investigate and figure out what went wrong. This is really important because a lot of times as engineers, we'll just want to jump in and like try solving all those problems while forgetting that, well, actually, we still have this outage in place. Okay, another big part of embracing failure is making sure you know what your error budget is. This is a term that really became popular with SREs, and it equally applies to the DBRE world as well. So things to consider there. Next point. What levels of experimentation do you need? What are the things you want to be able to try out? And next point. While being able to balance that out with the level of risk that you can afford. So really, you want to say that instead of being 100% available all the time, what really is the percentage that makes sense for your business? Some cases it might be 95%, some cases it might be 99%, some business might even have 99.99%. That percentage there, the minimal percentage, gives you some room to work around with. And that's where SLOs and SLIs really come in place because that allows you to measure what your system metrics are and then work out what levels of uptimes and what SLAs you can reasonably support. Again, stuff like this, these are the things that a DBRE can help other engineering teams by building these guardrails and this infrastructure in place so folks can essentially do more of the self-service. Next slide. So yeah, I hope I've convinced you that gas stations and DRE are a lot more similar than not. Self-service is the common idea. And we talked a little bit about automation, the journey of a DBA to DBRE, as well as embracing failure. The points that I've called out there are some of the things that can help essentially building those guardrails and really enable self-service, where we're not just saying that it is only the DBA or the DBRE team that is responsible for the data reliability. It is everybody's problem. And with that, thank you very much.
Awesome. Oh, so good. So the best question I've seen come through the chat, we just gotta ask it because you're here. Where do you go when stuff goes down at Stack Overflow? What do you Google?
Well, the good thing is we don't have to Google anymore because, hey, guess what? We have enough observability in our systems. What we've been doing over the past year and a half, especially, has been building in a lot more metrics and logs so we know what is going on with our systems. So if something breaks, we can essentially see a request come in and be able to trace that through. We have dashboards set up. I don't think this is any proprietary information. We leverage Datadog pretty heavily as our observability tool. And we have all sorts of dashboards that my teams have created where we can go in and see, well, you know what, there's something weird with this spike, or hey, someone's DDoSing us. Okay, why someone wants to DDoS a free community site, I have no idea. If I ever find them, good luck to them. But yeah, because we have that built in, and because of some of the other things that I talked about in terms of the rollback processes and having smaller change sets, we're able to mitigate those issues.
So that's awesome. You took a complete joke of an answer or a question and you made it into a real answer, and that is some skill. I love that. So
It's not the first time I've heard that. Trust me. I've been to college
uh,
campuses and like with students coming up. Yeah, they love asking that question.
yes, you can see that we have the I've got the maturity level of a college student. So there was another funny one that I just want to throw out there before I actually get into the questions, which Renjith was saying that your comparison of the gas station on fire, it's not fair, because if a gas station is on fire, at least you can run away.
Yeah, I mean, that's why I said how to not light ourselves on fire. The idea is about preventing the fire in the first place. I know I put in disaster girl in there and it was like, well, stuff will happen. So yeah, if stuff does get lit on fire, unfortunately, we have to roll up our sleeves and jump right into it.
Yeah, nice. All right, so there's some real questions. It's not all fun and games here. John's bringing us to the real stuff, so thank you, John. Um, let's see. How do you manage the starting point of appropriate data models for new projects? Keying, data types, naming conventions, etc.
Well, what really helps there is to have standards. I imagine a lot of companies have some sort of, I don't want to say architectural committee because I don't want to make it sound like gatekeepers. What I really look for is essentially almost like a guild style approach where cross-functional members members of cross-functional teams come together and pool their ideas and agree on what set standards are. Again, there will be a lot of disagreements. The idea is you make sure you can disagree, but commit to it so that we can move forward. But there has to be some kind of standards that everybody in the company follows. Once that's in place, that's a good template to get started with. You can look at what previous projects have done. But for me, what is the most useful is making sure that we work very, very closely in collaboration with our product folks. This isn't just any pure engineering problem. We're not talking about, some engineer going off and designing an entire schema in isolation. Really, we're trying to think about what are the problems we're solving. For me personally, and this is not necessarily something a lot of folks agree with me, but I like to think of it from like an API perspective. It's like, what is my schema? What is the contract that I'm defining? And then I use that. What are the operations? Like, what are the different types of data objects that I'm looking at? What are the interactions between them? What are the associations? And then leverage that to define out the data types and the models. I don't know if that helps answer the question.
Yeah, why don't people like to look at it like that? Why is that a hot take?
Not necessarily a hot take. I would say a lot of folks just want to dive straight into like UML modeling or like, jumping right into the database aspect of it. I really think of it from a REST perspective, so it doesn't necessarily always line up. But the idea is the same. You want to be able to define like essentially what are the things you're talking about, what the relationships are, what are the methods or what are the actions you want to do on them. And then that, once you have those mapped out, along with the standards doc that I said, which defines like how you should name things, how you should be calling your relationships, that really helps in defining a clear data model that is not just something that makes sense for your project, but is also something that can be maintained down the line.
It's basically start at the end. Start with the end in mind and then work backwards from there.
Well, in an iterative fashion, you want to solve like the most basic problem first.
Yeah. So you talked a lot about different things getting lit on fire or how to avoid lighting things on fire. What are some of the main headaches that you have as like a data reliability and director or as a SRE that is dealing with the data reliability?
I'm trying to think of some good examples that would be relevant here, because we've had some issues over the past couple of weeks. I'm trying to pull out like a real example. But one of the things that we keep running into is that Stack Overflow has been around for almost 15 years. We're entering year 15 this year. And when we started off, there wasn't a lot of great observability tooling out there. So one of the things that we did was, all right, why don't we start shoving exceptions into our databases? Cool, made sense at the time, but when you end up with terabytes of data, yes. So that's something that's an active problem. So that's an example of like, really, we have to go in and re-architect a bunch of things. And how do we essentially leverage tooling that is actually specialized for that problem, for example, like Datadog, and be able to leverage that for exceptions rather than shoving them into a database and then having the database just keep growing exponentially. Another thing that really worries me a lot is because there are so many different engineering teams involved, it is how to avoid making breaking changes. And one of the big things for us has been, how are we able to test things out, which is not in a production environment? The challenges that we face are kind of, well, our production database is like terabytes of data. Replicating that entire thing as a pre-prod environment would be a huge cost and also a maintenance nightmare. So how do we get enough of a representation of production so that we're able to test out the stuff that I actually talked about in my slides? That's a very real problem that we have. How do we get confidence that we have enough of a representation of production? How do we put in enough automated tests there so that when a change ultimately gets out to production, we know that it works, rather than, yeah, we'll just roll it out and see what happens.
There's the SRE's favorite line, I only test in prod.
Yeah. And my team is tired of hearing me say this, but I'm like, no YOLO shit to production.
Yeah. So this is interesting because one of the big gotchas I feel like in ML ops is that you don't have access, or you're not using the data that you have in production to actually do stuff with in your staging environments with machine learning. If you have that much data, how are you, it goes back to that question of like, how do you make sure that you have an accurate representation without duplicating everything and having gigantic amounts of data flying around?
Yeah, I mean, there's tons of great literature out there online as well regarding this. It's not an easy problem. It really depends on how much cost and how much effort you're willing to put in. If the database was small enough, I'd be like, yeah, let's just make an exact copy of it and keep it maintained and refreshed at a regular interval. But if it's something that's gigantic, there's just no way possible to have it. So it's about coming up with heuristics of figuring out what a good, reasonable representation is. There's two things here. So one thing is, first, you want to make sure, I'm talking about it from the application perspective, when you're rolling out changes, you want to make sure that the changes actually work. One of the best ways of doing that is actually by leveraging integration tests and having mock data in place. With mock data, you can even model out scenarios like the database is not available, or 2 + 2 gave back 5 for whatever reason. You can't force the system to do those weird edge case scenarios, but with mock data, you can. So with the application code that you're writing, if you write out these mocked out integration tests and run them, there's a very high degree of confidence that the application code works. So that is one way of getting around this problem of not having a true pre-production mirror of your production environment. The other part that you said about ML and ops, that I think is really more of, I would say, a data lake and a BI issue. So what organizations are increasingly doing, including Stack, is having essentially a secondary data store that essentially sucks in data from production, is able to pull in data from various sources, including the main production database, so that folks can make associations on those. And on top of that, we slap on BI tools so that analysts can go in and use it after the fact. Because there's a difference. Like for ML, it's a different use case versus what we were talking about production, because production is for the live site. We want to make sure the sites stay up. But for ML, it's really more about the analysis and things like that. So I would make that distinction.
Ooh, awesome. I hadn't thought about it that way before, but it makes complete sense. So this has been great, but it is time to go.
Yep.
And I thank you so much for coming on here and teaching us and giving us some laughs. And this was really awesome. And if anyone wants to reach out to you, I think you are jumping on the chat, or what's the best way to contact you if they want to stay in touch?
Oh, they can find me on LinkedIn. And yeah, I'm going to jump on the chat in a bit as well.
There we go. All right. So thank you, Ellora. And we're going to keep on cruising.
Cool. Thanks.